All right. So I just posted some of the due dates for this week in Blackboard. So chapter 5, tomorrow we'll talk about that. And basically Wednesday night, Thursday night, 14 and 15 respectively, and then Sunday would be 16. So that's the game plan. So questions from chapter, we'll just take the chapters in order, chapter 10. Any of those you'd like to review?
Look at 3 on the apply.
Number 3 on the apply. Fair trade cocoa. Fair trade cocoa. All right, you're an economist for an NGO that is organizing a certification program for fair trade cocoa producers. Assume 1, the annual output of land is 100 units. The annual output of land is 100 units of cocoa per hectare. Initial price of cocoa is $12.40. Farmers have bank accounts that earn 10%. The labor cost for cocoa workers is $400 per hectare. The other non-land cost is $200. Under fair trade agreement, farmers will increase wages to $500 per hectare. Predict the quantitative effect, number of a wage boost on the market value of cocoa. All right, so what was the answer?
P equals 600 to P equals 5,400.
And that's the price of cocoa.
And it says increase P by $1.
So what did you say, price equals what?
600 to 5,400.
Like a range?
No, that's what it changes to.
It changes to 5,400.
Oh,
That's like the equilibrium
So
price.
P1 and P2 is 5,400?
Yeah, those are the equilibrium prices.
Okay.
And then it says increase P by $1.
All right. Which is probably, is that the answer to B then or something?
Yeah, I got a lot.
Yeah, what would it make
Yeah,
it
it
neutral
was-
with cocoa land? Okay, so what'd you guys do with this one? Kind of looks like the indigo one a little bit,
I
right?
made a slightly messy graph.
Slightly messy graph. So were you able to justify the answers?
I could justify the 600, but I was struggling with to get it to the 5,400.
Yeah, I also can justify by changing price by $1.
Okay.
I don't know the
Okay, so how'd you start the problem? It looks like some leftover stuff going on here, right? 100 units. How did you start the problem off? Predict the,
I just started graphing like between the total costs, the labor costs, and the non-land costs, like all in the same graph, and just display like the differences after.
okay. Did anybody do just an equation?
I tried.
Because this looks like the leftover, looks like our indigo problem, doesn't it? Kind of similar. What else you guys do who are being quiet? Zeke, Andrew, Jameson, Kalen, McKenna. Look at this side of the room.
Yeah, you can set it up in the PV. I did it with the PV equals R over I. That's the formula that I did.
Oh, with a,
But if you're using a less.
so present value, you're talking about our cap rate formula. So present value equals basically the annual return you're getting on your land divided by the interest rate was the value of a perpetuity, right? Okay, and so what did you do with those, Andrew?
Well, if that's not going to be the equation, because I don't know, I just set it up that way, but I couldn't get it to 400 no matter how many times I try it or what
Okay.
I use. So
Fair enough.
that's the best way that I can do it because I thought it would get me back formula, but if it's gonna be a leftover principal, it's not gonna be that formula.
So what is the value of the land? What you guys, did you do a leftover? Yeah, Carlos?
But I got 640.
Okay, how'd you do it?
I did the price times the quantity.
So the price times the quantity is the 1240 times the 100, right? So that is our total revenue basically, right?
Minus.
So if we're thinking about the leftover principal, then we are taking the total revenue minus total cost, which, what do we got up here for cost? So 600, where's that coming from?
400 for the workers per hectare and.
Wage plus the return on that.
Okay, so we got labor, and then we've got
Cost.
the non-land cost of the other 200. Okay. And then is there any other cost?
What about the opportunity cost of the bank accounts? Does that count?
The opportunity cost of what?
The bank accounts, the farmer's bank accounts?
Well, that's gonna be our opportunity cost that might play into what Andrew was bringing up if we had to value things that way. So right now, this is going to be our profit equation. So what do we get? 1240
640.
minus the 600 equals 640. So now that is the leftover amount that would be able to be put towards the land if it was valuing the land, because that's what we had left over, right? And then we got this, because right now they had the 400. So basically the problem's trying to do the wage boost from 400 to 500 is kind of essentially what we're trying to grapple with. All right, so market value of the cocoa land. So using Andrew's method there, what's it worth?
$12,400.
12,400, how'd you get that?
I did the 1240 of the revenue, subtracted by 10%, or divided by the 10%.
Okay, it's not the revenue though, this R here is the rate of return, basically, the residual in this case.
So 640.
So if you're a landowner, you've got that money coming in, there's all your cost outside of land cost, so you've got 640. So then using the willingness to pay maximum anyway with this, what is it?
6,400.
6,400. So it's 640 over the interest rate, which is a tenth, gives you 6,400. Would be the land value currently under those circumstances. So the quantitative effect of the wage boost under the market value of cocoa land. What happens? Kaylin, what'd you have for this?
I didn't know how to do it.
Okay.
Nothing I wrote makes sense.
Well, the cost is going to go up by 300. Or was it 100? 100.
So yeah, if we had the cost go up to from 400 to 500, what does the market value change to? If 540, well the leftover is 540, which then makes the market value change to 5,400. So with the new wage, so leftover star, leftover 2, leftover 1, we still get 1240 minus 700 equals 540, which then implies the market value of the land of 5,400 instead of 6,400. So predict the quantitative effect on of the wage boost on the market value of cocoa land. So the word, when the author uses the word illustrate, it's not always, it's kind of explain, graph, possibly equations. It's not always necessarily a graph. We didn't use a graph with this one when we did the indigo farmer. Okay, so the answer they gave was what?
Price from 600 to 5400.
Yeah, so it looks like I get that. I think this looks like an error then, right? I'm thinking that's your 6,400, and this is the price. When they say price, it's really looking at the value of the cocoa land, using the way Andrew did it with getting the value through the perpetuity through the income stream. All right, so describe an amendment to the fair trade agreement that would make it neutral with respect to the market value of cocoa land. Under a fair trade agreement, what would the idea of neutrality be?
Is it indifference between like going with the cocoa land and doing the next best thing? Is it?
Yeah, I mean, it's always, you're wanting to hold something fixed, right? So I like when we did back in macro class, I don't really use it anymore. I can't remember if any of you guys are still lingerers of the fair tax plan, where we changed from a 23% federal sales tax, but abolish the income tax. No more income tax at all. Does anybody remember that from macro? Just curious. Lawson, you were still in those? That was a while back, and now, especially now that we changed tax. But so the idea of it being neutral of a tax change is that you can set the sales tax at some level. It turned out to be 23% sales tax, collected on paper anyway, the same amount of tax revenue. Let's just say it was 100 million of tax revenue, versus a mix of a zero sales tax and the income tax. So the income tax collected 100 million of tax revenue. What if we got rid of the IRS and just did a sales tax? So it was revenue neutral in that there's some tax rate that would collect the same amount of tax revenue that something did, right? So we're kind of holding something fixed. So describe an amendment to the fair trade agreement that would make it neutral with respect to the market value. So we'd be wanting to hold the market value of the cocoa land constant. So what would be an amendment that would be friendly to holding it at basically 6,400?
So compensate the wage increase by going with a different tax plan is what we're getting at.
Well, maybe. I mean, the author just said what could be done. Is it possible to do that? Is there a way to monkey with some of the numbers there to create a neutral land value? What variable could we pick to keep it at 6,400 is what we're trying to do. So we got 6,400. How did we get that number? It came from the 640. Where did that number come from? We had the price of cocoa and the units minus labor minus other non-land cost.
So would you give give out like $100?
What's that?
Would we give out $100 then?
Where would it come from?
It's the price,
What's that, Jacob?
the initial price.
The initial price. So do something with the initial price being bumped up enough. That would be one way to do it, right? So if we had the price now, can we basically pass a law that says it needs to be $13.40 instead of $12.40? Yeah, would that be a good idea? Usually not. We're going to screw up something else, probably. But you guys got the right idea. You could have something of a benefit. Maybe it is an external subsidy of some sort, to where the laborers are granted a subsidy from somewhere. If the interest rate changed, right? So what would be? Let's say it fell to 540. What would be the opportunity cost change here? What would be 540 to make it 6,400? Why don't you guys do that one?
$640.
Go ahead, get your calculators going. That'd be another way to do it. Again, not sure if it's a great way to do it, but looks like you guys got some answers, but you're not being very brave here.
0.08.
0.08, yeah, so 8%, so basically 540 divided by 6,400 equals 0.08 or 8%. So an interest rate of 8%, a concession by them of 8% would then make it math out. That would hold this constant. So there might be some ways. So we talked about the price bumping up or somehow changing. Maybe there'd be some other things. Some of these things have to be fixed, but that would be the direction I think you'd head, is if interest rates are going to fall from 10% to 8%. But good news, you're going to get extra $100 worth of labor. And then that would maintain the value of the land at 6,400. Okay, any other questions there? All right, other problems? On any on chapter 10 before we move to the next chapter?
One, please.
1. Okay. Green Jeans grows corn on the land and rents at a price of $500. Suppose Green Jeans develops a new genetically modified organism, a GMO, that decreases production cost for corn by $300. Green Jeans will pay land rent of $800 if, so land rent of $800 if, how'd you guys do this one? What's the answer?
No patent on GMO.
No patent?
No patent on GMO.
All right. Okay, so what'd you guys do?
I just said if they don't get a patent, then everybody else is going to do it, which in turn would just raise the land cost. So they have to pay more. And since they're decreasing production cost by $300, it'll increase their rent by $300.
Okay, so then the leftover principle would apply and it would just be sucked up with that if they didn't have any protection. Okay? Jameson, did that make sense? So yeah, thinking about that leftover amount. I mean, that's kind of a weird, weird answer that you wouldn't exactly come up with that the copycats, being able to copycat would help. But the idea here is thinking about property rights. If you do develop something that decreases production cost to 300, that's a valuable thing, right? And so that does leave that extra 300 on the table, and then we could go back and do extra 300 on the table means that land prices, you know, if it was 300 divided by the interest rate, we could see a deviation in land prices of $3,000 or something because of that, if we got back to the price of land. Okay, any other ones on this chapter? Yep.
One on the review.
One review. If a hectare of land generates $100 of rental income per year and the market interest rate is 5%, the market value of the land is, what did it give you for an answer?
2,000.
2,000. Okay. And what did you get?
I get 95.
95.
Yeah.
Jameson?
You use the equation that Andrew, that the PV equals R over what I.
This?
Yeah, and if you just divide it out, it's 2,000.
Gets 2,000.
And you get to
That's how it works
2,000, yeah.
Well,
So in class, remember I spent a bunch of time like thinking about the value of the income stream. That's where this formula comes from. It's a bit simplistic, but we're converting cash flow per year into what's that worth to me today, right? So the present value of $100 per year forever, when my opportunity cost is 5%, is $2,000 today in my hand. In other words, I would be indifferent. Another way to frame this is to say, I would be indifferent between you giving me $2,000 today or $100 a year for the rest of eternity. I'm indifferent between those two, right? So that is how we value that income stream is worth $2,000 today. And so that's the price today, or the value today. Okay, any other ones? All right, chapter 11.
We do 5 on the fly.
5 on apply. I didn't see who asked this. Andrew? 5 on apply. Oh! Was this our skip one?
Skip on B.
Oh, part B. Okay,
Yeah.
so part A is what you wanted to go over, Andrew?
Yeah.
Okay. All right, consider the implications of switch from office buildings made of stone to those with steel. Suppose the switch in technology does not affect the capital required for a one-floor building. For a standard office building, 5,000 square meters of space, a one-floor building requires 5,000 square meters of land and $100 in capital regardless of the construction technology. The common input bundle, 5,000 and 100, anchors the isoquants for stone and steel. Draw 2 office building isoquants, 1 for stone, 1 for steel. All right, so who's got a picture? Lawson saw you first. All right, what's going on with your picture?
So stone did have this steeper slope along the isoquant than steel, and I was assuming that was because it's stronger or steel is stronger and lasts longer, so you don't need as much of it. So you'd have a bigger lot size in comparison to stone.
Okay.
That was just my thinking.
Anybody else? So, so basically, let's kind of review the trade-off as the book, as we did in this chapter. The lot size, so the lot size needs to be bigger for your steel versus the stone. Because I'm thinking along your Isoquant, you've got the two inputs, lot size and capital.
Should those be flipped then?
Yeah, what do you guys think? Who else did this one? Or took a stab at it? So the Isoquant, let me just do a quick little review here. So let's just say we've got labor and capital. This is, not all of you have had the intermediate class. Capital means machines here, whereas sometimes we talk about it in terms of dollars. And of course, we're talking people here. And so if I want to make 100 pizzas, I can do it with a whole bunch of labor and a few machines. So 2 machines and 10 people. Or I can do it with kind of 50-50, or I can do it with a real fancy bunch of machines and 2 people. So this would be a labor-intensive way to make 100 pizzas. This would be a capital-intensive way to make pizzas. The point is I can use less labor and more machines, or more machines and less labor to make pizzas. With that picture, I'm not talking about the cost of labor per unit or the cost of a machine per unit. I'm merely looking at the engineering of it. It's possible for me to make pizzas with any various combinations of labor and capital. So that's what the Isoquant does for us. So here we've got now lot size and capital. And the way we use capital in class here, it's probably equivalent whether we talk machines or buildings or values, but dollar values of how much we need to spend. So more or less lot with stone versus, let's go back to the problem here. So suppose the switch in technology does not affect the capital required for a 1-floor building. So capital for a 1-floor building would be the same. For a standard office, 5,000 square meters of space, a 1-floor building requires 5,000 square meters of land and $100 in capital, regardless of the construction technology. The common input bundle is 5,000 and 100. So they kind of give an anchoring point of 5,000 and 100. Is for what? What's that combination getting us? A 1-story, 1-floor. So my pizza, my Isoquant here is the idea of a 1-story building. Okay, so now draw 2 Isoquants, one for stone versus steel, when we switch to stone buildings and steel framing. So now would it look the way Lawson's got it here? Where do they intersect? Where do they intersect according to the problem here? The common input bundle anchors the Isoquants. Suppose the switch in technology does not affect the capital required for a 1-floor building. 5,100 is our anchoring point. So now which one goes where? So it looks like we've got maybe something going on like this versus something going on like this. Which one's which?
Stone is steeper.
The steep one is what?
Stone.
The stone. As we start to go up. So So smaller lot size, but you gotta spend a bunch of money with the stone as opposed to the steel. Steel's less costly as we go. Okay, so I wanted you guys to think through that a little bit. I'm just gonna tell you, I'm not gonna put that on the test. So, still put it down in your notes, but I mean, the idea of the isoquants is fine, but you can put not on test if you want. Because that's why I wanted you to think about the isoquants, but you can do more stuff with them that we're not ready to do. That's why I had to skip the other part. Okay, any other ones on this set for chapter 11?
Can you do one is applied?
Number 1. Hoverboards. Consider it. Oops, is this right? No. Yes.
Yes.
Okay. Consider a central business district where workers from office firms interact to exchange tacit information. Suppose hoverboards are introduced, doubling the travel speed on sidewalks. Illustrate the effects of hoverboards on the willingness to pay for office space at different locations. Is that the one you wanted to go over? Was A or B or both? Okay. So illustrate the effects of hoverboards on the willingness to pay for office space. So what did you guys put, Jonathan?
I didn't draw a picture, but I said since they could go faster and longer distances, the willingness to pay is just going to go up.
Okay. So they're able to pay more for office space.
Because they can go twice as fast, yeah.
Okay. So in terms of the leftover principle, there's more left over, right? So when we think about the willingness to pay, for office space, we've got all the, basically the non-land, the office bid rent, we've got total revenue minus total cost, leaving the leftover for the office space to pay. And so now, if it's less costly, then that allows us more to pay. Anybody else, comments or questions on that? Is that what by the way, what the answer say? I forgot to.
It says it helps landowners B.
Helps landowners what?
For part B, it says it helps the land.
Did A have anything?
Increase in willingness to pay, change of willingness to pay increases with X.
Okay. So showing that out would be, having the interact, and so the key here that is the exchange of tacit information for office firms that they're saving money on the cost. So once this goes down for that chunk, then this goes up. And then in the long run, the bulk of the benefits of hoverboards go to, who does it go to?
Landowners.
Landowners. So over time, that helps bid up prices because you have other companies coming in and they bid up office rents. Is that good, Jameson? Other ones? Yeah,
3 on the review.
on the review.
Yes.
Workers in firm T commute by public transit while workers in firm C commute by car. Firm blank has a steeper willingness to pay for office space, will outbid this to the city cluster. Okay, so what did you get for the first fill in the blank?
It's T.
Firm T. So workers commute in by public transit while workers in firm commute by car. So they're going to have a steeper willingness to pay curve. Why would that be? Steeper means higher willingness to pay or lower?
High.
Higher, yeah. And why is that?
They don't pay for gas or anything?
They don't
Yeah,
want
nope.
to travel as
They'd
far.
rather be close to the public transit so that people can actually get to them.
Yeah. So which one's cheaper, basically? Car or the transit?
Transit.
The public transit's going to be cheaper than the car. So that's the idea that you have less cost to the employee, which means they don't have to pay them as much, back to the leftover principle. And so they have a higher willingness to pay, or steeper willingness to pay. And then firm what will outbid firm what for land closer to the city?
T will outbid C.
T will outbid C. So T will have a higher willingness to pay or be able to afford land closer compared to the ones that are coming by car. All right, anything else on this chapter?
7 and
7 apply. Tallest building. All right, for an office building in a large city, the profit increases with the number of floors for the first 40 floors at the rate of $3 per floor, and then decreases as the number of floors increases at a rate of $2 per floor. In addition, the prize or bonus from the tallest building is $30. Two firms, A and B, will each build one office building, and A gets to build first. In the event of a tie, the two buildings of the same height, there is no prize. What's the Nash equilibrium? Is that what you're wondering? Is part A or other parts?
Basically the whole program.
Okay. So Nash equilibrium, what'd you guys do for this?
I mapped it out and then explained it. It was at the 90 and 55 floors that it hit Nash equilibrium.
How did you map it out?
So at 55 floors, they get 90, but they also get the $30 bonus, and no one wants to go past that.
So it's 40 floors times 3 up to the first 40 floors, right? Plus, and then was it as tall as you want to go after that?
$2 for.
Right, at $2 per floor. So now it's $2 per floor. Plus, oh wait, that's just the cost. So that kind of sets up the cost, right? With the height. Notice what we did here is we're just assuming that 40's already done. Like 40's almost taken as given, and so then we can just have a nice simple equation of 2x for the remaining floors past 40 is one way you could set it up. How did you, what did you end up doing? Did you create a schedule?
I should have written it down. I made a graph and I made a curve and then mapped it out on each section.
Okay. So let's see, do we have any revenues to deal with this one? No, so we just got the cost part, but we can hold revenues constant, so it doesn't really matter, and just look at the cost maybe?
It says the profit increases with the number of floors at a rate of $3 per floor. That's not revenue.
So for an office building, the profit increases with the number of floors. So we are all looking at profits, not cost. So this was profit over here. So this was profit. And then if you're the tallest, then you have the plus 30 on here too, right? If you're the tallest. Yeah, Tyler?
That probably has to be
Minus the 2x. Why is that?
because every floor you go over 40.
So then decreases as the number of floors increases at a rate of $2 per floor. So profits are actually going down after that. Okay, so minus the 2x. And that's for floors 41, right? So the extra floor above it. All right. So then where do we go from here? What's the answer, by the way? The Nash equilibrium for A?
55.
55. And so in the event of a tie, there is no prize, the Nash equilibrium. So we're doing this with the prize here for the first one, right? So why 55?
Building A gets built first, so they get automatic choice of if they want the prize or not. So they would build the extra 15 floors, cost $30, the prize would cancel it out, they'd still be out $20 profit.
Okay, so what are you setting equal to solve for 55? Or did you guys plug and chug 55 because you had the answer? Or, like, imagine you don't have the answer. How would you do it? You know, would you want to do 41? Would you want to do 42? You know, what is it at 50? And is that what you said? You made a table, Lawson? You said something about.
So I made a graph, and I'm kind of figuring out what I did now. And
Okay.
I wrote out the slopes, and just by doing that, I could calculate from the floors what the profit was going to be.
So it's kind of, a graph could be like this, right?
Yeah.
So what would this thing look like if we take it with or without the prize? So we've got the 40 times 3 is how much?
120.
120 plus the 30 would give you 150, starting at, we could start this at 40, and you'd get the 150 if you were the tallest at 40, at a height of 40. Would that be right?
Yeah.
And then if I do 41, what happens? I lose a couple bucks. But if I'm still the tallest, then I'd be fine. So 148. And if I do two floors above, 146. Okay, and then, so that would be kind of going down something like that scale. If I'm the second highest, what's going on?
You're just doing 120.
At 40, you're at 120, right? So you'd be, oh, I tried to pick a different color, not blue. 120, and then what would the slope of that look like if I do 41?
Same slope.
Same slope. So we got something going on like that. So then how do we reconcile them both? What would you do if you are A, if you get to move first, where would you want to build to? Where would it not be profitable for your second player in a sequential game
56.
to not do it? Jonathan?
You want to do 55.
Okay, so how'd you find 55?
Because you have your original 40, you're going to build 40 no matter what. And then since you're going first, you're trying for the prize, which if you do 2 times 15 equals 30, and the price breaks out. So you have 55 bullets.
So, by the way, would this guy want to for sure do 40? Or would 39 be better?
40.
Wants 40. Remember, 39 this would start to go down, right? So this is the profit maximizing amount for 120. So what's my break even to keep him away?
You have to basically use up the $30.
We got to use up what?
The $30 prize.
Yeah, we got to use it up essentially.
Just use it all the way up.
So how do we use it up?
You do $2 a floor, so then you end up with 15 extra floors.
15 extra floors. So we've got something like that. Let's just play around. I mean, we got this thing kind of floating out there, but this would be our 120. So 150 minus 2x equals. We can just play around. I mean, this would be my total profit equation, right? Including the prize. So what should I set this equal to? 120. Let's see what happens. What do we get? 2x, throw that over there, throw this over here, equals 30, x equals 15. What is x? It's the additional amount of floors above 40. This equals 55, this is 15. Nice. Yes?
What is it? I could make it hard on them by not giving them the prize, and I guess we both lose those.
You always have to assume profit maximization. So their underlying motive is they're not going to hurt themselves in terms of profit. We don't allow spite and other, you slept with my wife and I'm going to build a bigger building. I don't care about money. We don't allow that crap in econ class in an economic model. In the real world, of course, that happens, and so that we might have something to talk about. But that's why knowing this gives us the baseline to start from. Then we can start saying, well, what if you did sleep with my wife? Then this might be screwed up, right? And then we have a non-monetary cost of $10 because I would have sold her out for 20 anyway, so it doesn't really matter. And we can come up with some other crazy set of circumstances. But you always just have to work with what you got. Work with what you got for profit maximization. Okay? All right, so anyway, the competition to be the tallest building changes total building profit by, how much does it change total building profit? Now here they're trying to compare like total building profit for each, but how much does each building owner earn? 120. So that's our equilibrium. So if you remember when we did it in class, you could combine the two profits together. And so if would they be better off somehow if we allowed somebody to do to be 41, and then the person with 41 actually got the $30, then the total profits combined together would actually be higher. So it's kind of the prisoner's dilemma idea. If they could collude with each other and buy each other off somehow, they might be able to increase total profits between them if it's not a non-cooperative game. And then design a Pareto improvement for which two firms share the gain equally. Okay, so that would be if we collude with each other, or we have an equally tall building. So what did it say for equal tall? I guess it kind of said, in the event of a tie, two buildings at the same height, there is no prize. So what would we do now for C? Design a Pareto improvement, which means an improvement that makes at least one person better off without making anybody else worse off. Z?
It says A gives $14 to B, and that's because if they do 41 and they get the 16, they subtract the 2 from the extra force, and they go for $14 extra.
Yep, and so then they're just sharing the prize essentially, right? One of them gets a little bit of a hit on profit, but then the other one makes it up to them with 16 versus 14, right? Okay, anything else on this chapter? All right, so chapter 13, there was just the apply problems. Did anybody have any, or the review? I guess it says review and apply the concepts, but it was really just these.
5.
Number 5, for the typical commuter, the maximum walking time to a transit stop is about 1, 3, 10, or 40. So a transit stop can serve households within X meter radius. All right, so what was the answers?
10 and 800.
10 and 800. All right, how'd you guys solve this one? So for the maximum walking time to a transit stop is about 10. Was that from data in the chapter?
Yeah.
Yeah, that's what I thought. This is one of those.
206.
So we're kind of reviewing. So a transit stop can serve households within, and then how'd you get the 800?
It's in the last paragraph on page 207.
Okay, last paragraph, page 207.
It says for the typical commuter, the maximum walking distance to a transit stop is 10 minutes, so a transit stop can serve households within an 800 meter radius.
Okay. So taken right from that data. You said I lost which paragraph?
207, it's above that graph right there.
Just this little one here?
It's gonna be right above.
Oh, in
Should be
here.
right now.
Okay, 800 meter. Okay, yeah. So a transit can serve 800. So there's a little bit of reading comprehension from this section. Who asked this one? I can't remember. Jonathan. some of those reviews do that. And we'll have other ones that do kind of similar too, like some of it is from some actual data. All right, anybody else on this chapter, 13? All righty. Good deal. So, chapter 14 is the monocentric city. Okay, so give this a read. All right, what do you think monocentric city means?
Only one big city center.
One big city center. So mono means what? We break this sucker apart.
One.
One, and it's in the center, right? So one center city. So the way they saw traditional cities developing, you had all the action here, and then you had these little spokes. So the idea of the monocentric city was something like this, but it's kind of dead now. So that was old time cities. What do you think killed it? A lot of the things we've been talking about in class, what caused all the action kind of happened here with employment and everything, and then the city kind of
Suburban
looked
living.
like spokes a little bit into suburbia and some other stuff. Awesome.
Cheaper suburban living compared to the center of the city.
No. That's not what killed it. That's not what killed it. Is it? Transportation. So transportation innovation. So we're going to go way back to horse and buggy. Whoops. Break my thing here. So trucking and the automobile. So we can kind of think of the automobile allowing people to get there, and then trucks may be just as important compared to horse and buggy, that they can move product from one spot to the next. And so that caused, we didn't need everything centered here. Some of this might have came in on other rail systems and roads, made it convenient to set up that way, but it eventually died on us. So a lot of these cities, of course, still exist, and so some of the remnants of this design are still there for cities that were in the 1800s. I grew up around that time frame. So give this a read. What's agglomeration?
Clustering of businesses.
Some cluster. Why are they clustering, Tyler? Or just in general, whatever you want to say.
Because they can make more profit.
Okay, because it's profitable to group together. Why is it profitable to group? This was our previous chapter, part of the test. McKenna, we haven't heard from you yet. I'm going to go to you guys who haven't talked yet, so be ready. Agglomeration. They're all in one place, and why does it make it more profitable? What's good about that for the workers?
They just have better options.
Oh.
They can be in one place and be like, oh, I like this one better than that one.
Okay, so there was shared work opportunities was one, a common labor pool, right? Was one of our motivations, a common labor pool. What else, Gabe? clustering. Why did businesses find it profitable to cluster together? Good, knowledge spillovers, right? So the ability of people to talk with each other, and then some of the things that we learn, maybe we learn it at the bar for a beer after work, and some of that knowledge spills over. Okay, good. Carlos, did you have one? Intermediate sharing, intermediate input. So all of that stuff back from the previous chapters was some of the reasons we'd have this clustering back in those days. Okay, so just for a footnote, mass car production, Model T Ford, not until 1920. So we had plenty of cities going through the Industrial Revolution into that 1800s and early 1900s. When was World War I? 1917. So just kind of keep a mental note. World War II, 1940s, late 30s-ish time frame when they were fighting. So that is kind of the state of the world, just to keep in mind as we look through some of this stuff. So we still get, with these innovations, this still makes sense, right? So we had businesses developing here. We now have a subway that brings us through the spokes or whatever, and the electric trolley if we're in San Francisco, and cable cars. So all of that still worked with this system to bring people around. And then we had the innovations in buildings to allow them to get taller as well, and changing part of the value of land, that we can go up at a cheaper rate. With one of our graphs here, our costs would change with new innovations that came up. Okay, so why do we see offices rather than manufacturing firms? So what's going on with this picture now, we've kind of done this in previous chapters. We're thinking about areas of the city in regard to this monocentric concept that we can then apply in different ways later, but we have offices, manufacturing, and then we get to residence, and then agriculture. We could be farming here, but we're not. Now we're gonna farm over here somewhere. So as we step through and get closer, so the question is, why is the center occupied by office firms rather than manufacturing firms? Let's go to Mackenzie. Why is the center area, which is 0 here, or we can think of here, it is offices that are outbidding manufacturing? So think about manufacturing for a second. Which one has, just from what you know of office, think of an office building, think of a manufacturing plant, which you might not have stepped foot in, but you can use your imagination. Which one has more people per square foot? Office or manufacturing? What's that?
Would it be the manufacturing?
Why?
Because they're all more.
So which one has more workers per square foot though? Is there more? If you take a space like this, would an office building have more people in this room, or would a manufacturing plant have more people in this room? The office building, right? So why do we want to keep office people closer together than manufacturing people, workers, is what I'm saying. Office workers versus manufacturing workers. Why do we want to keep them closer?
Like they give each other like ideas or something?
Okay, yeah, for ideas, face-to-face transmission, Jameson?
Like costs, like wages or something like that?
Yeah, so part of their daily work deals with face-to-face interactions and other things, especially back in those days, right? Did they have Zoom in 1893? Right? They didn't even have phone. Well, I don't know when the phone was invented, I can't remember. But basically, it was all face-to-face interaction. So it was all the more important in the old days. And that made their businesses more profitable, which allowed them higher the ability to pay higher rents. Okay, so manufacturing less so, but still have a need to be in closer, but not quite the same in terms of the production process. So kind of to wrap that up, this is kind of a similar question to what we just covered, but a little bit different. You know, why do all the manufacturers' office firms locate in the center, far from their workers in the residential district? So I want you to think about the residential district being further out, and they're saying, you know, well, why wouldn't you be here? I mean, why? The workers are here, so if you need lots of workers, wouldn't it be better to have a sub-center? What do you think of that?
Public transportation.
Okay, so transportation's an issue. Transportation of what?
Workers to jobs.
Workers to jobs, and what's the alternative if I locate my company out in the residential district? Then what do I have to transport? Your goods, so it's either your output or your input if we're back to that transportation model. And we can talk about it in terms of the output, whatever that is. From an office standpoint, the output might look different, but maybe it has to be mailed somewhere or sent, distributed somehow. So we've got that same tension that we've seen before with our transportation model. So this is distance from the center. And so Bryce and I were talking last time to kind of think through this model. Sometimes it can be a little non-intuitive on what X means, but always just go to what the freight is. So what is this saying here? Freight cost versus labor cost. So what's going on by me bringing labor cost is going up as I travel this direction? What's that saying?
It's cheaper.
It's what?
Cheaper to bring the labor.
Okay, so for the labor, it's cheaper versus what?
Right?
Versus the freight. So it is still that location principle that we did before. So the total cost, where is it the lowest, and why is it the lowest, I guess is the main thing, is that here, if we have zero freight cost, if we're not bringing our freight anywhere, then we're just going from one office building to the next office building, right? It's like a real estate agent bringing paperwork over to the attorney. And they're just going up one set of floor to the attorney's office and they're saying, here you go, right? So it's essentially zero. Whereas if we start to move some of that freight, and this would be a combination of manufacturing and office, it would start to be more expensive. So it's cheaper for us to bring our people from the suburbs to the center. The slope of that line is less expensive, shows the rate of transfer of basically the commute cost. And so that's a cheaper way to get there. Okay, questions or comments there? All right, so again, this is really unrealistic in terms of some of the things we talk about with federalism and other things. But bear in mind, it's just an economic model. So we have people that move according, and they're all kind of equal happiness depending on where they move. But so we're not allowing the cities to be differentiated and other things. Just thinking about how and why they're going to move from one spot to the next. Okay, so What is the population density is the same at all residential locations? How would you put that into words? Residential location, you can think of it being a city. Population density. Jacob.
Same amount of people living in the same, like, space.
The same space. So we're holding the space fixed, right? So when we see different things with per square kilometer, per square mile, how many people do you have per square mile? That's all we're thinking about with density. And employment density is the same also in the business locations. How many workers do I have for some fixed amount of space? Okay. So we're going to tie back in labor supply and labor demand. So we're same model here. Agricultural prices, they could be anywhere, right? In the city, we're kind of holding fixed. The fertility of the land would be reasonably the same here on the ground below us in Ottawa versus that out in the 10 miles from here on the farm. The actual soil conditions are the same. So agriculture basically doesn't matter where they are. They're going to pay a certain amount per acre. But at some point out here, residents, these guys outbid the residents. Why?
Because they don't want to live that far away from their job.
Yeah, so this is going up because of the commute and commuting cost. And so eventually this would just be too burdensome of a commute. And so the residents would be that far out, but I'd have to be buying the land this cheap for me to justify that big of a commute and transportation costs. The farmer's like, no problem, I'm gonna farm this anyway, right? So the farmer's going to outbid the residents because of this commuting function. And then as we move closer and closer to the city, of course, the businesses start to outbid the residents because it's more profitable for them to do so. So how does that connect over to our supply and demand framework? So the labor supply and labor demand, who's the labor demand curve? Is that businesses or households? Households? Businesses? Yeah, I always like to throw that out there because it's always opposite. If we're talking beer and pizza, so the quantity of beer, the price of beer, we usually think about the output market. The demand for beer is the households. But in the resource market, it's the businesses that are trying to make money. They're the ones who want to buy workers for their production process. So the labor demand is here, the labor supply, and so the interaction of those two are going to determine an equilibrium wage and number of workers. And so you can kind of start to tie the number of workers and the density. These workers are living here but working here. So which one is there a higher density? In the center, right? So when they're working, they would be in a more dense environment than when they're living. So living space is less dense than the other space. Okay, so now we have an innovation. So the innovation is the streetcar. Why did this shift up?
Because it's easier for them to move.
It's easier for them to move.
Transport.
And so what else? So it's easier for them to keep going with that thought. Or if somebody else wants to add on to Jonathan, it's easier for them to move, right? For sure. But this is a bid rent function. So why did it move from here now to here? It's easier for them to move, totally agree with Jonathan. But why is this up? Jameson.
They might be more willing to live like farther away from their business, but that might be less like costly if you have to drive or.
So again, keeping our leftover principle mindset, right? We're always thinking about what is my maximum willingness to pay for housing. Now the streetcar, I used to spend $10 getting to work. but now it's a $2 fare with the streetcar. That gives me $8 extra to be able to potentially afford to pay more for that. And it opens it up for multiple people. And so then that got us an expansion of the residential area. Why does the monocentric city witness an excess supply of labor? What is an excess supply of labor?
Too many people are looking for jobs.
All right, too many people, yeah, so excess supply, so let's go back and think labor demand, labor supply, oops, labor supply. There's the wage, there's the L, the number of workers. So where does an excess supply of labor, why does the monocentric city witness an excess supply of labor?
When the wages are too
Okay, the wages are too
high.
high, so then there's a surplus of labor, an excess supply of labor. Okay, so what happened with the streetcar?
The supply curve is gonna shift to the right.
Okay, so the supply curve shifts to the right. And why is that?
Increasing supply.
We have a greater range of labor because the range itself got larger because of the streetcars.
Okay, so households' opportunity costs changed, right? On what they were willing to, the wage they were willing to take went down. So one way to think about it is this worker used to require, just to put a number up here, $10 an hour. This worker used to require $10 an hour to come work. But now that there's a streetcar, I can work for less. Right? Now that there's a streetcar, I can work for less. So what that means is that if we look at the original wage, with the streetcar, we now have an excess supply of labor at the original wage. So what did we learn in principles class is going to happen to the wage?
Goes down.
It's going to go down. So when an excess supply of labor, then we're going to have a fall in the wage to this new level, W2. Maybe it's $8 an hour just to make up some numbers. So why does the monocentric city witness an excess supply of labor? Because people can afford to pay more. They can take a lesser of a wage. So a couple different ways to think about that. Now what happens to the business bid rent function? Does this have any effect on the businesses?
Yes.
Yes.
It's gonna shift it up, right?
Can they afford to pay more for office space or less? More. So that innovation then trickled into them paying less wages, which would bump up our ability to pay. All right, I think that looks like a good spot. We'll pick up there tomorrow. So Triumph chapter 5. Triumph chapter 5. Go knock that chapter out for tomorrow before class.